Hello everyone. This is a video on how to use LTspice for filters for EC412. So first of all, if you go to the LTspice link on the course webpage, you will see some instructions. First thing to do is to click on the download link and go ahead and install LTspice for your computer, either Windows or Mac. Once you've done that, just go through the installation. It should be pretty simple. And then you should make some kind of folder on your desktop or elsewhere, call it EC412 for example, and then download these three files in there. Okay, so there's the biquad ASC, biquad PLT. Just put these two files in that directory, and there's a zip file here. Take this zip file and extract it to the same the location that you created, EC412 or whatever directory it is. Once you're done with that, then you're pretty much ready to go. So let me start off from that point. Okay, so I've done that. I have a EC412 directory, and if you simply go on that file biquad.asc and double click it, LTspice should launch automatically. And if you click the running man, you should be able to run the simulation and a plot should automatically appear, and this confirms that your design actually works. So that can confirm basically that everything is installed and that directory is active. Okay, so now let's start entering in some like a new filter or a new design. So to do that, what I'm going to do is simply close off this graph window and open up this file here. And it's important that to get all the library files, etc., that whenever you create a new file, that you save it in the same folder as you have put all this information, right? The folder that you created, EC412 folder, everything should go there. Any new file that you make should be saved in that directory. So if you go, if you opened up this sample file called biquad.asc, this is definitely in that folder. So what I'm going to do is we'll just modify this particular file to make our new circuit. I'm just going to make a very simple circuit to show you how everything goes. So what I'm going to do is first I'm going to cut many of these things out. So if you get the cut symbol, click the left mouse button down and drag, you get a little window, okay, and then just blow it away, okay. And we'll just leave this waveform behind. So if you want to get rid of the cut, you can keep cutting. Cut is still active right now. Right click and it goes away. Now we're in the entry mode in LTspice. We're always going to use in this kind of a source. This is just a phasor source, amplitude 1, phase 0, right? So this will sweep frequencies for our EC analysis. Okay, so we can just start from this point of view, or from this element, and just go on and build our circuit. So how do we get the components? Well, for example, resistors and capacitors we can just get from here. Up here we have resistor and capacitor. So if you click here, you can get a resistor. You want to rotate, you just say Control R. So Control R, Control R, Control R will rotate, and then left mouse button down, click it down. It basically puts it where you want, and it's still active now. You can put another resistor down. Maybe you can do Control R and put another resistor over here, for example. Click, and when you're done with putting down the resistors, right click to get out of that mode. Enter in the capacitor, pull a cap, left click, that's all the capacitors that I want. Right click to get out of that mode, and then we need to do some grounds, right? So here's some grounds that you can pick, maybe one here and one there. So now we have grounds, or maybe make it a little lower here. So you want to move things, you have to go and say, for example, move, right? Here's move. You can also move components this way, okay. And just play around a little bit, then you'll get used to it. And you want to get out of that mode, always right click gets you out of the mode. Wiring, go to this pencil tool, and you can actually go right through the components and wire and click, 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 and we're done. You want to get out of the wiring mode, right click. So now we have our circuit ready, but the component values are not given. So R1, R2, C1, leave those alone. That's just the way that LTspice designates component values. But you want to enter these values for R's and C's. So to enter values, for example, for R here, R1, right click on where it says R and enter in the value. For example, 1K. Okay, 1 kilo ohm. And for example, this one, R2, let's enter in 5K. Okay, and then for C, let's enter in 1 microfarad. So it's 1 U. Okay. So now that's done. Next thing to do is maybe designate this node up here, the output node, as out. You know, you don't need that, but it helps. So when you go to a node and you right click, you'll have, it'll say, for example, label net. So if you go label net, you can name it anything you like. For example, out, and you'll get this text with a little box, and you just click it where you want it to be. And when you're done, just right click to get out of that mode, and now we have input output, and our circuit is done. We can zoom full extent to sort of show it on the whole screen. You can do zoom out, you can zoom to a particular rectangle, zoom to content, or you can scroll, zoom in and out that way too. So you can try all these. Well, right now we're ready to simulate. The only thing is we don't have the simulation command. We can enter the simulation command, or we can still, or we can just hit run. If you don't have a simulation command, LTspice will ask you for the simulation command. So let's go to run. Okay, and we want to do AC analysis. So we're right here, and type of sweep, we typically pick decade. Okay, number of points per decade, 100. Where do you want to start and where do you want to end? So these are in hertz. So let's say we want to start at 1 hertz and we want to go to 100 kilohertz. We can always change these later, but you click OK, and the simulation runs. And you can click on on the waveform, or we can get the waveform by just clicking on a node. Notice if I'm in the graph window or the schematic window is highlighted, and when you hover over it, you'll see that the probe is going red. So I can click on that, and I'll get a my frequency response, right? Now the thing is, you're seeing V out here, but what we're plotting there's actually V out over V in, but since V in is 1, we'll get the same value. So we can actually change this to V out over V in. First of all, let's get rid of this empty plot here. The way you can do that is just right click in there and say delete this pane. In your case, you might not have that up there. I got it for some reason, whatever. So if I want to do V out over V in, I can go to the name of the graph or name of the plot. It's called V out. It turns into a hand. If I right click on that, instead of V out, I can do V out divided by V in. So actually what it's going to plot is, it's going to plot 20 log magnitude of V out over V in. That's what it's going to plot. If I say OK, you see I get really the same plot because V in magnitude is 1, so it doesn't really matter in this case. That's because we picked our V in to be 1 at 0, so really V out magnitude is the same as the V out over V in magnitude. Okay, so this is the way we kind of do it. Then you can build more circuits. Like for example, let's get an op amp in there. How do we get an op amp? Well, you can get a real op amp, but if you're in this directory, if you're in the working directory that I just told you about, you can also get the ideal op amp. Let's just get an ideal op amp with some very simple filtering as well. So let's just do tile vertically here so you can see both. What I'm going to do now is I'm going to add an op amp, an ideal op amp. So typically when you pick components, you go to this AND gate symbol, and there's a lot of components here. In fact, you can go to op amps and pick real op amps, but ideal op amp actually is gotten from the local current directory that you're in. That's where the ideal op amp model that I have made is. So if you go to the set that says top directory, click on here, it'll list the working directory which you saved your file. So if you click on that, you should see a bunch of basically components, bunch of custom components. Click on ideal OA, which is the ideal op amp, OK it, and now it's on your screen. So if you just do scroll up or scroll down, you can zoom out and you can just place it someplace. For example, over here. And I just got an ideal op amp there. So right click to get out of that mode, and let's just wire up another filter here. Let's just wire up a simple filter. So maybe I have well, first of all, I want negative feedback, so I want to put this upside down. So let me just rotate it. To rotate it, I have to either move it or drag it. I have to click one of these buttons. So let me click move, and I highlight the op amp. So when I highlight the op amp, now I can move it around, but it's in this highlight mode that I can also rotate it. So I can do Control R. Okay, then I want to do maybe Control E. Control E is a mirror. So if you want to mirror something, you can do Control E. By the way, all these things are under edit. So if you look under here, you will see all these things that I'm really talking about, the move, the drag, etc. And you can see rotate is Control R and mirror is Control E. But you see they're actually grayed out. That's because to use Control R and Control E, rotate and mirror, you have to first select it here. You have to first select, for example, move. If you do move and you look in, now you see they're actually active. Okay, so to Control R, Control E, to get into the right position, your components, you have to go to the move or the so move or the drag mode. What's the difference between move and drag? So we say move, you can actually like move a component, take it out of its location. If you say drag, it'll stretch the wires. That's the difference in the schematic. When it's open like this, it doesn't really matter. So now we're in a position, and let's just do a little feedback here. Maybe we want to put a little bit of a gain here. So I'm going to get a resistor. So let's just put a resistor here, and do Control R and get a resistor there. Do a little ground. Okay, right here. Let's just wire this up. Okay, so wire. Let's do a gain of 10, right? Okay, and now we have a new node here. So let's just call this out 1. Okay, out 1, and say okay, and put that there. And since we want a gain of 10, we want to go on R4 and make that 9, for example, maybe 9K, and then make our 3 value 1K. That will give us a gain of 10, so 20 dB boost. So out and out 1, right? These are two different voltages. Out 1 will be 20 dBs higher than out, but the shape should be the same. Okay, so we're ready to look at the simulation now. Okay, run the simulation again. Okay, this didn't change obviously, but let's go to out 1. And you see out 1 is 20 dBs higher, right? You can do a lot of things in here. For example, I mean, obviously we're plotting out 1, but like I said, if I did V out 1 divided by V in, I will get the same thing. Okay. If you want this on separate plots, we can just right-click in the graph window. Okay, right-click in the graph window and say Add Plot Pane. Okay, and then we just drag. We just go to the name of the plot, left click, drag, and you got it. Okay. If you want to change the frequencies, for example, if you just go to the command, right? In fact, we can move this command. Okay, highlight the schematic window. We can say, for example, drag, take this and move it around someplace. For example, we can do that. But if you want to change the simulation command, just right-click on the simulation command, and then maybe you say, I only want to go up to 10K. So change this high limit to 10K, OK it. Run it again, and so now we're up to 10 kilohertz. We're going from 1 hertz to 10 kilohertz. Maybe the lower end is might be changed too. So maybe I want to go from, I don't know, 10 hertz to 10 kilohertz. Okay, and then rerun the simulation again. So you can see how we can change all these, and it's quite easy. You just gotta get a little hang of it. Now, having said all this, now the question becomes, how do we make some small adjustments to this, and how do we get that out? How do we print it, etc. My suggestion is that that you don't print these directly, but you put them in, let's say, a Word file and print that, whatever your preference is. And to that end, though, if you simply capture these windows as they are, you're going to be wasting a lot of ink. So let's say you wanted to capture this. Okay, so what I'm going to, let's say that, let me just show them how to capture directly, and then let me show you what my recommendations you do. If you simply want to capture the schematic and the graph as they are right now, do not do print screen. Okay, first of all, like for this graph right here, or sorry, the schematic, simply go to Tools, and then it says Copy Bitmap to Clipboard. Click on that, and with your Word open, for example, okay, with your Word open, so I have just a blank document here, just paste, and there you go. Same thing goes with the graph, by the way, right? So if I go to the graph here, okay, and if I say Tools, Copy Bitmap to Clipboard, and then you're in Word again, paste, you get this. But this is going to be, you're gonna waste a lot of ink. Plus, it's not gonna look nice. So I suggest you do not do this if you intend to print it. Okay, if you intend to print it, here's what you should do. Okay, so let's just delete these because we don't need these. Okay, here's what you should do. You should go to okay, let's just go to our graph, for example, and you should change the background to be white. Okay, if you choose the background to be white on both the plot, okay, and the schematic, I think you'll get a lot better results when you copy them into Word. This is just my typical suggestion. So how do we change that? Well, we're going to change that from the settings. The settings is under the control panel, which is under this little hammer symbol, just to the left of the running man. So if you click on that, okay, you'll see that there's an item called drafting options. So click on that, and under drafting, as you see the color scheme. So just go to the color scheme, and you can see this is how typically the schematic will look like. What we want to do is we want to change the background. So basically, just click on the background, and the selected item will change the background, or just from the drop down list, find background. Okay, and what you want to do is you want to change until you see the color that you like. So maybe if you do 0, 0, 0, right, it goes all dark. You don't want that, so just the other end, basically 255, 255, 255 will give you white background. Just say okay, and you're basically there. Okay, so this will give you the white background for the schematics. Now, for the plot, okay, for the plot, there's a different setting in a similar place. So here you go to, again, control panel, waveforms, similarly, okay, color scheme, okay, with the cursor, just click on the background and you see 0, 0, 0, okay, make that also 255, 255, 255, okay it, and now you have this window now. You have this plot with the white background, which is just fine. And if you want to change the color of any particular waveform, you can just go to the, let's say the bottom one is green. If you put your cursor right on the name of the graph, name of the basically name of the variable you're plotting, if you simply left click, you'll get this cursor, okay? And you can move it around, and you can look at all this stuff, and the frequencies and things like that. We'll do more of this later. But for right now, what I want you to do is, if you don't like the color, if you right click, okay, you'll see default color. You can change it to something else, like red, for example, and okay it, right? So if I don't want this blue up here, again, right click, and I can change it to something else. Okay, something else like that, okay? Usually little darker colors will look better when you copy and paste. So let's just copy and paste now. Okay, so let's go to the circuit. Here's a circuit. Do the same thing, okay? Just say Tools, Copy Bitmap to Clipboard, go to your Word file, paste, okay, paste, and here it is. It'll look a lot cleaner. And if you don't want the grid, you can even remove the grid, but usually the grid is not the problem. Okay, and then the graph, go to the graph, tools, copy it up to clipboard, okay, and then go to Word, and then say Control V, and you're in business. This is how I suggest that you do. I mean, if you want, you can put these on separate pages. You can make landscape to make it look bigger. You can do all that, but this is a lot better than trying to make it the other way, which is all dark, and it's very hard to see when you print it. It's usually unreadable if you print it. So this is what I suggest that you use for the homework submissions. So we'll do more of these things. I'll show you more and more tricks with it, etc. But I think for now this should do it in terms of how you use LTspice. Okay, the key is, right, make sure that you are in that working directory where all those files are, right? If you create the LTspice file and do not save it in that directory, then it will say, where's the ideal op-amp? Or it won't find the ideal op-amp. And remember, the way you get the ideal op-amp is you go to this component, and then you find your working directory where you store your 412 stuff. You find that file, and you should have a bunch of custom models, basically. Ideal OA is one of them that you can just drag into the document. So I think I'll stop here. I think this should have you working pretty efficiently, I hope, but it takes a little bit of a while to get used to the front-end entry, but it's not that difficult. It's actually very straightforward. Try it out, and if you have any questions, of course, you can ask, but I don't think you'll have too much trouble. You can even start with the original file and just update it, right? In this case, I rewrote over bytecode.asc, but really what I should have done is I should have said file and save as something else, right? So that usually works better. And then after that, you're not really starting from scratch every single time. You're starting from a known circuit and then, saying save as and then cutting things out and modifying it. So in that way, you might not even have to re-enter this voltage source or even ideal op-amp. You just copy and paste from the single one, multiple instances. Okay, so I'm going to stop here, and I'll see you in class. I hope you have a good day. I'll talk to you later.